Hi everyone! In this video we're going to be talking about graphing logarithmic functions. So how do we do this? Well, just like we have with our linear and quadratic graphs, when we plot them by hand, we're going to want to start with a table of coordinates. So we have our x values on the left-hand side and the y values on the right-hand side. In order to capture the behavior of a logarithmic function, it's best to plot more points because then we can see more of the behavior, especially when we start talking about asymptotes. So for log functions, I would recommend plotting at least 6 points. So let's first look at, if I have a table of x and y values, how do I find the y value? How do I evaluate them? So let's look at these three tables that I have, three different log functions. So the first table, we have f of x equals log of the quantity x minus 1. And you'll notice I have x from 1 to 6, and then I have plugged in to my equation on the right-hand side 1, 2, 3, 4, all the way to 6 in for my x's. And then in the next function, we have g of x equals the natural log of 2x. And again, I have my x values ranging from 1 to 6. And then on the right-hand side, to find my y value, or the value of my function, I have plugged in those respective values for my x's. And then same thing for our last function here, h of x equals log base 3 of x. Again, going from 1 to 6 for x's, and then plugging those into my equation. Now, after we've plugged these in, we now need to find what's the value of our log when x is that value. And so we can use our scientific calculators. So let me pull one up here. So when we are evaluating our functions like our f of x here, where it's just log, or in other words, the common log, or log base 10, we get to use our log button. So it should look something like this. It should just say log. And your calculator may or may not pull up these parentheses. If not, I would recommend to put the parentheses, especially if we're doing an operation within them. And then we're going to just plug in what we're taking the log of. So when x equals 1, for f of x, we're evaluating log of the quantity 1 minus 1. So I would plug in a 1 minus 1, close parentheses. And then you hit enter. Well, in this case, you'll notice on the right-hand side, what it returned to me was an error, or it's undefined. And so this tells me that log of 0 is undefined. We can't find a value that satisfies that. And if you think about this algebraically, so if we think about log of 0 and what this equals, well, what if we put this in exponential form? So our base is 10 because it's the common log. Our exponent is what we're looking for, our answer of the log, and then our value is 0. Well, if you think about this exponentially, what power of 10 would get us 0? And there isn't one. There is no power, so therefore we can't find a value that satisfies this equation. All right, so then if we continue and we want to evaluate g of x when x equals 1, well, this time we're working with the natural log, or log base e. So on your calculator, it's going to have an ln. Okay, and then you'll click the button. And then again, if it doesn't pull up parentheses, I would, because we are performing an operation before we want them to take the log of it. So in this case, we're evaluating the natural log of 2 times 1. So 2 times 1, close our parentheses, and then hit enter, and we get approximately 0.69. And we can continue in the same way for f of x and g of x for all of our values of x. But What if we were trying to evaluate our h of x function, which is log base 3? Well, if I go back to my scientific calculator, there is no log base 3 button. I only have the common log and the natural log. So we can't use our scientific calculators to evaluate this function. So we're going to need a special property, and that's called the change of base property. There are two different ways you can use change of base, and that is first to get it in terms of a common log. So if we had, and let me use this example, so here we have log base 3 of x. So in this case, our b is our base, which is 3, and our m is what we're taking the log base 3 of, which in this case is x. And so when you rewrite this in terms of our common log, you're going to have log of whatever we're evaluating the log of divided by log of our original base. So if I were to rewrite this, it would be log of x, because that's what we're evaluating at, divided by the log of our base, which is 3. Same thing with natural logs. We still have the log of whatever we're evaluating the log of on top, and then divide it by the natural log of our base. So in this case, we would have the natural log of x divided by the natural log of 3. Applying the change of base property, now we would be able to use our scientific calculator to evaluate h of x for each value of x. So let's go ahead and do so. So here we're going to graph the equation h of x equals log base 3 of x. And all I did here was I copied the table from above and added some extra columns, one for applying the change of base property, and then the other one to list our final coordinates that we would be using to graph. And so we are going to first look at when x equals 1. So if I'm applying the change of base property, instead of log base 3 of 1, we're going to be able to do log of 1 divided by log of 3. We could, like I said, also do it in terms of the common log. So natural log of 1 divided by the natural log of 3. And let's see what we get for each of these. Are they equal? And so pulling up my scientific calculator, the first one I'm going to do is common log of 1 divided by common log of 3. And so I'm going to put in my division first. So common log of 1 divided by the common log of 3. And we get 0. So let's see, do we get the same thing for our natural log change of base formula? And so here we have the natural log of 1 divided by the natural log of 3. And we do in fact get the same thing. They are both 0. So here my y value is going to be 0, and our x that we used to get that value is 1. So our coordinate is 1, 0. Now we can do the same thing for x equal 2 through 6. We could use either one, the common log or the natural log change of base property. They are both going to be equivalent. So it does not matter which one you choose. You can choose whichever you prefer. So I'm going to use the natural log one. So we have now log base 3 of 2. Using the natural log change of base property, we get the natural log of 2 divided by the natural log of 3. And I'll do this one more time using my scientific calculator. So we are going to have the natural log of 2 divided by the natural log of 3, and we get approximately 0.63. So now here our coordinate is going to be 2, 0.63. All right, and then same thing. So log base 3 of 3, changing bases, we get the natural log of 3 divided by the natural log of 3. I can tell without even using a scientific calculator that we're going to get 1 because we have something divided by itself and it's non-zero. So here we have the coordinate 3, 1. Keep going. So log base 3 of 4. Change of base, we get natural log of 4 divided by the natural log of 3. And that is approximately going to evaluate to 1.26. So here we have the coordinates 4, 1.26. For log base 3 of 5, we have the natural log of 5 divided by the natural log of 3. And that is going to be approximately 1.46. So here our coordinates are 5, 1.46. And then log base 3 of 6 becomes natural log of 6 divided by the natural log of 3, which is approximately 1.63. And so our last coordinate is going to be 6, 1.63. Now, one thing that I also want to look at is what if x equals 0? Because our behavior of our graph around the y-axis is also important. So I'm going to just tack that on here. So then we would have log base 3 of 0, which we're trying to figure out. So using change of base, we would have natural log of 0 divided by the natural log of 3. And if I pull up my scientific calculator for this, you'll see that we get undefined. And so in this case, we know that it's undefined for the same logic that I had used previously. So if we're looking specifically at the natural log of 0, if we put that into our exponent form, we would have the base of a natural log is e, to what power gets us 0. And again, just like we experienced before, there is no power of e that evaluates to be 0, just like there wasn't a power of 10 that evaluated to 0. So therefore, it's going to be undefined there. So that is one thing to also note as we are going to be drawing our graph. So I'm going to draw my coordinate plane. And remember, horizontal is our x-axis, vertical is our y-axis. I have x from 1 to 6, so I'm going to need to go up to 6. 1, 2, 3, 4, 5, and 6. I'll label every 2. All right, and then if you look in our y coordinates, we're going to go up to no higher than 2 in this case. So I'm just going to plot up to 2. And I'm also going to put hash marks in between for a half to help us with those decimals. All right, so the first point we have is 1, 0. So it's going to be right here. Go right 1 and then stay there. Then our next point is 2, 0.63. So right 2 up 0.63. So it's going to be a little bit past a half. Then we have 3, 1. So right 3 up 1. And then we have 4, 1.26. So right 4 up 1.26, so about halfway between the 1 and the 1.5 marker. Then we have 5, 1.46, so write 5 up just a little below the 1.5 mark. And then we have 6, 1.63, and so write 6 up just a little bit above that half mark. And then remember that at 0, our function is undefined. So as I am drawing the curve, that 0, I can never touch that graph because there is no value that would satisfy when x equals 0 or when we're at the y-axis. And so this is actually going to tell us that x equals 0 is a vertical asymptote. So when we come down from the points that we have drawn, it's going to get really, really close to that y-axis, but it's never going to touch it. So here we have graphed y equals log base 3 of x. So when graphing your logarithmic functions, be sure to create a table of coordinates. I recommend at least 6. Your teacher may have a different recommendation, so be sure to follow your teachers. And to evaluate the function for each x value, be sure to use a change of base formula. You can use the natural log or the common log change of base formula so that you can evaluate using your scientific calculator. I hope you find this video helpful and wish you luck as you're graphing your logarithmic functions.